It's literally going to take 5 minutes. I shouldn't say literally if I don't know that for sure, but it's not going to take very long, okay? So, what I want to talk about very quickly is just talk about what a chemical equation actually means, or what I can say when I look at a chemical equation, because it tells me a couple of different things when I'm looking at a chemical equation, all right? And this is kind of just to give you a little bit of a preview maybe of what we're going to be doing next unit, just so that you're kind of thinking about it in the back of your head. When I read this right here, there's a couple of things that I can say, and there's one thing that I cannot say, and I want to make sure that you understand that we can't say this one thing, okay? But the first thing that I can say here, I could say I've got four, well, what is this? This is iron, right? So I could say, so I have 4 irons. Sounds a little awkward, doesn't it? 4 what? 4 iron what? 4 iron pieces, like just big chunks of iron, or, I mean, is it something more specific than that? I think someone said it.
4 iron molecules.
Okay, close. We don't really call this a molecule because it's just one thing, right? Okay, so 4 iron atoms, right? Okay, so I could say I have 4 atoms of iron, which combine with 3 oxygens.
Oxygen gas.
Okay, it's oxygen gas. That's the state of matter it's going to be. So it combines with 3 oxygen gases.
Gas atoms.
Okay, we're getting closer, right? But this time it's 2 oxygen atoms together. What do I call that when 2 atoms are sharing electrons? Okay, it's diatomic what? A diatomic. Okay, maybe you haven't picked up on this when I say it, but usually I say diatomic molecule. Okay, diatomic molecule. I think sometimes I do say diatomic element, so I get if you didn't get that. But this is a molecule. Okay, you've got 2 atoms together combined. We're going to call that a molecule. Okay. This part over here is a little tricky because we haven't really talked about that yet. But so far, I'm going to say 4 iron atoms combined with 3 oxygen molecules to make solid. S just means solid. To make 2 iron oxides. Okay, now we're close. 2 iron oxide molecules. That's pretty close. Now the thing is this is this ionic or covalent? Ionic, right? Okay, because it's a metal and a non-metal. Usually, and I've mentioned this a couple of times, but that's it. And I don't really care all that much that you remember this, okay? But we're going to say here, technically, 2 formula units of iron oxide, okay? So that's the way that I would say this. I'm going to say 4 iron atoms are reacting with 3 oxygen molecules to make 2 formula units of iron 3 oxide, which I think, yeah, there we go. Okay, 4 atoms, 3 molecules, 2 formula units.
Iron oxide.
Yes, it would not technically it would be iron 3 oxide. You have to put the Roman numeral there because iron's a transition metal. But that's not really what I'm focused on right now. I'm just focused on how do we actually say an equation like this? What does it mean? Okay? So what that means is this is the right ratio for this thing to react. In order for a reaction to happen perfectly, I need 4 atoms of iron, 3 molecules of oxygen, and I'm going to make 2 formula units of iron 3 oxide. It's kind of like a recipe, right? Like you combine this much of this much of that, and then you're going to make this. That's your cake at the end, right? Or whatever it is that you're making. So that's your ratio. Does that make sense? Now the other thing that I can say here, these coefficients also equal a mole ratio. Okay? Now here's why. Do you remember what a mole is? It's been a long time. 6.02. Very good. Okay, 6.02 times 10 to the 23rd, right? Okay? So if I have 4, this isn't working. Okay, there we go. So if I have 4 atoms of iron, okay, then I have 4 times 6.02 times 10 to the 23rd, that would give me the number, well, okay, actually, no, I'm doing that wrong, sorry. Maybe that didn't look right. Yeah, it has. I'm not going to explain it that way. I think that's confusing. Basically, what I need you to know here, these numbers can tell me the number of atoms, the number of molecules, the number of formula units, but it can also tell me the number, like the mole ratio, okay? So in other words, if I have 4 moles of iron, that's going to need to react with 3 moles of oxygen to make 2 moles of Fe2O3, okay? So I just need you to know that's going to be a mole ratio as well. The reason why is because these are all 3 of these are related to the number 6.02 times 10 to the 23rd, okay? So if I wanted to figure out how many moles I have here, I mean, this is a little more detail than I wanted to go into here, but you remember if you change atoms to moles, you put atoms on the bottom, you put moles on the top, right? And then you got 6.02 times 10 to the 23rd atoms in 1 mole, okay? You're going to do the same thing over here, right? So if I've got 3 molecules, and then you've got 2 formula units, which I'm going to abbreviate, please forgive me, but I'm in a hurry here. I'm not mad at you guys or anything. Okay, so basically if I take 4 divided by 6.02 times 10 to the 23rd, and I take 3 divided by 6.02 times 10 to the 23rd, and I take 2 divided by 6.02 times 10 to the 23rd, they're going to be different numbers, but they're going to have the exact same ratio. Does that make sense?
Yeah.
Because I'm dividing them all by the same number, right? So this is still a 4 to 3 to 2 ratio, okay? Just like it was before. So that's all I really care that you know here is that these coefficients, they can be used to tell me how many atoms or molecules or formula units I have, but they can also be used to tell me how many moles of something that I need in order to combine in the right way, okay? And that's going to come back into play when we start talking about stoichiometry in our next unit. Yeah, some of you are just scared by that word because it sounds like a weird, scary word, but you'll be fine with stoichiometry. All right, so that's all I wanted to show you on this. So we're done with that. We're going to start on another worksheet that, like I said, we'll be working on probably today and tomorrow. Okay?